Matthias asked me to give a talk about some Docker-related stuff, and I hammered some slides on the weekend. So bear with me. I don't know how long it will take, and it's the first time I'm giving this talk. So I will talk about container orchestration, and this. Jürgen already said that Docker is fine, but there is lots of tooling needed around Docker. So, and that's what this talk is about. First page.
It has a switch.
Yes. Yeah, it has a power switch, but it was on. So I work for a company called GiantSwarm, and we're currently building a platform as a service for simple service orchestration, which is built on top of Chorus and Docker. That's why I'm looking at all those technologies like every day. And we're based in Cologne, and of course we're hiring. It just works one time, and then maybe it's empty. So this is how everything should look like, right? So you have like a huge boat, you have your cranes, and you're ready to get the containers. So this is probably the blueprint we're looking for. But as I will show you, there's no one solution for that at the moment. So we're still at the beginning, and it looks like this, right? So, why containers? Containers are not new. Yeah, Jürgen already said that. So, what Docker did is solving packaging and distribution of those containers. And they solved it really well, because there's a hype around that, and lots of applications are now packed in containers, and they're available on the Docker Hub. And so developers are starting using containers, and so DevOps operations are looking into how to run those containers in their environments. So Docker is doing some kind of standardization for containers, and the ecosystem is really growing around that. And so we want to have something like that. So we need orchestration, and with orchestration, the main thing that is complicated in infrastructures at the moment is that there are things like polyglot resistance or microservices, where developers start using small services with a tool that is actually the best tool to do the job, but it's not like always the same language. You don't take like Java for everything. If you want to build a service which is perfect for Python, you're going to choose Python for it. And if you need a message queue and it's good to use RabbitMQ or to use ZeroMQ, or you need a Hadoop cluster or Ria or CouchDB or whatever, you're going to choose it. And so you have lots of tools around in your environment, and that's going to become really hard for operations, right? And the other thing is you always want to have high availability, and you want to have a good utilization of your machines. And so this is what others are already doing, like Google and Twitter, and they have their orchestration tools, and I will present them to how to schedule containers. Like you have different types of jobs, types of tasks. You have like long-running tasks like services that are running or databases. You have batch jobs that are maybe long-running, maybe CPU intensive, maybe I/O, maybe lots of memory. You have to figure out what kind of job is it and how to deliver that job to a certain set of machines to have the best utilization, right? And what is necessary is to have like a configuration management for that, service discovery because you have like distributed system and those services have to find each other, and you need logging, monitoring, alerting. Currently there are many choices. There's core, as Jürgen already mentioned. You have Kubernetes from Google, which is recently open source, and there are some kind of ideas from 10 years of containers running at Google built into Kubernetes, but it's not their internal system. So it's actually a prototype to get feedback from the community. You have Apache Mesos, which is more mature, a bigger system to run containers. You have shiny new products like Consul from HashiCorp, which is the company which does Baker and Packer and all that stuff. And you have Project Atomic from Red Hat, which is similar to CoreOS. And will at one point become the new operating system for OpenShift, I guess. And so many companies are working on that problems. Actually, somebody from the Google Core team told me that when they saw CoreOS the first time, they thought, oh, this is the operation system we always wanted to have. And that's yeah, quite interesting to see that it's a company that does containers for 10 years, right? So this is a slide from the DockerCon from Solomon Hykes, and this is how it looks at the moment. You have like at the top is your Docker client. You're building your container, and then you have in production. You have maybe Consul. I guess Helios and Centurion was from Spotify and Relic tools. Like everybody did their own tools. Everybody had the same problems and built their own tools. And so you have Shipper, Geardy, Mesos, Fleet, and then you have like different cloud providers. And that's how it looks at the moment. And what Docker tries to do with that is to also standardize those different tools. And it's not ready. It was announced, but if you ask a developer that works on this form, they say, okay, it will be probably rewritten like several times until it's ready, because they have to figure out how it will look like. But the idea is to have like the primitives of container orchestrations, which are similar to what you can do with a Docker client, like Docker start, stop, run, whatever, and build those into like different adapters for all those technologies. So you can still maybe use your Docker client, but in the end, it's just an API facing your CoreOS cluster. Something like that. So, yeah, you probably won't figure out more if you look at the code in on GitHub.
This one is just a library, as it says.
Yes.
So there's no current product which uses that.
No. No, they have they have Beam, which is just a protocol to have those Docker verbs like start, stop, linking or stuff like that, and then they have adapters currently for EC2, SSH, Core OS, but they're just, you know, roughly sketched up, and I don't think that there's anything ready to use. And it's not integrated in Docker. So it's not in the Docker client. You cannot use it at the moment. So this is how the data center looks. And this is something from Mesos, from all the presentations about Mesos you find out there. It's like, is somebody running a Hadoop cluster here? Or any other big cluster, MPI, whatever? So at Twitter, they have the problem that they have like a Hadoop cluster, a Spark cluster, a Storm cluster, and they were all doing similar things, but they had like strengths in real-time performance or batch processing with high bandwidth, whatever. Like, they had different usage for those clusters, and those clusters were running different loads at different times, but they were statically partitioned. So like you have 9 machines running Hadoop cluster, and you have like 6 machines for Storm. And they wanted to change that. And you can see that here, that you have like different loads, and if you combine them, you have better utilization of your cluster, and you can even run more jobs at a certain time in your Hadoop cluster. So what we want to have is like an operating system for the cloud that acts like actually one computer, and you don't have to mess up with all the distributed software architecture problems. So I think there are 3 main types of schedulers at the moment. Google Borg is the old Google cluster scheduler, which was monolithic. That means that you have one system, you tell this one system, there's a new job, please run it. And there's only one scheduler for all the different types of tasks. So the scheduler became more and more complex over time because it had to handle like short running jobs, like huge batch jobs, long running jobs, and all those different types. And it became more and more complex. So that's why Twitter decided to have a 2-level approach. You have a resource manager, which actually gives resources to another scheduler that schedules his job on the resource. And you can have different schedulers for each kind of problem. So you have a scheduler for Hadoop, you have a scheduler for Spark, you have a scheduler like Marathon for long-running jobs, you have a scheduler Kronos, which is kind of a cron, and Mesos has the resource manager that gives away the resources to those schedulers. Okay? And Google then tried to build a new scheduler, and it's a paper, it's out there, it's quite nice to read, and they figured out that there are certain problems with the 2-level approach, and they have like different schedulers that share state. So each scheduler knows about resources and does it himself and has an optimistic approach to try to get those resources, and F2 try to get those resources, one fails and tries to get another resource. And they found out that it's much more efficient than the Mesos approach. But this is just theory, because they are not open source, either Borg nor Omega. So what Mesos framework for those distributed environments, and you can build schedulers on top easily. I don't think it's easy, and I watched a talk about Twitter's Aurora, which is similar to Marathon for long-running jobs, and they have like 40K lines of code, and they still can't do service discovery, and there are several other things that are missing. So it's just running jobs for a long time, and if it fails, it restarts the job. And they have some like gracefully failing and some resilience inside there, which is really nice. But I think it's quite complex. And I try to run. Actually, I try to run everything in containers. Like I'm even running cores in containers on my computer, and I tried to run Mesos in a container, and it didn't work out, and I had to fetch a different GCC for it, and then the test suite failed, and it's a huge amount of Java code, and it's a framework, but in my opinion, it's really broken, and it's not something like Unix philosophy, sharp tools for the job, and I don't know. I'm not a big fan. But Mesosphere is trying to build a pass upon Mesos for web application, because originally it was from Twitter and it was all about those Hadoop jobs and like batch jobs. And Mesosphere, when Google announced Kubernetes, they said, okay, that's a perfect match, and they're trying to port Kubernetes to Mesos to build the scheduler for Kubernetes. So this is more how Mesos looks like. So you have like chips with chips, right? Yeah, these are the different schedulers that are out there. Demos, yeah. It's officially from Derstappen. Yeah, so we have Kubernetes, which is not Omega, but they say it's already inspired by Omega. But if you look at Kubernetes, the scheduler is even not extracted from Kubernetes at the moment, so it's not easily pluggable at the moment, I think. So, but it's work in progress. It's really fresh, and I think it will come at some point, but it's still there. And you have Core as Fleet, which is actually very, very simple in orchestrating or in scheduling jobs. You have with Fleet, you can say this job has to run on the same machine like this job, or this doesn't run on the same machine like this job, or you have like metadata, and you can say, okay, this is a machine that has like high CPU, please run this job just on machines that have high CPU. You can do that, which is in lots of cases maybe enough, but it's not like Omega, which looks at the workloads and learns from it, and then schedule your job just like automatically. So what you need for your cluster is to have some kind of shared state, which is consistent. And this is why all of them are using a consensus algorithm, which actually, it's pretty simple to explain. Like, you have 3 machines, and if one fails, the cluster is okay. If 2 fail, the cluster is dead. Because you always have to have the majority of servers up and running, and then it's consistent, and you can write to your cluster. On the other hand, the benefit from that is that you cannot have network partitions. Like, if 2 machines from 5 cluster etcd cannot reach the other 3, then the 3 are working and the other 2 are not. You cannot write to them because they have no leader and they won't elect a new leader. Right? So it's consistent, but comes with the problem of like high availability. If like something goes wrong really hard, then it doesn't work anymore. You have to fix it yourself, right? But you have consistency. And Raft consensus is quite new. It's just a very easy or easier version, more practical version of Paxos. And Google has Spanner, and you have Apache Zookeeper and Dojo from Heroku. These are Paxos implementations, which are more complex, and Console and etcd, they're using Raft for it. And the GitHub page is actually really nice, because there are lots of talks and lots of implementations you can look at, and so if you want to learn more about that, it's quite nice. So, service discovery. Jürgen explained Docker links, which is something that only works on one single machine. You can link 2 containers together, but they're finding each other by a name and just through the Docker daemon running on one host. And then you have like environment variables to find out which IP or port the other container is giving you. And to do that across hosts, you have something like ambassador pattern. And I think I even have, yeah, so this makes it easier. So you have your load balancer over there. You have application on the right and database in the middle. So if your application wants to start, you first have to start your database. The database has a sidekick container which looks for the presence of the database. So the sidekick just watches the database. Is it there? Okay. Then I write information to etcd. The database is there. Then I can start the application container. And now before the application container, I start an ambassador that watches etcd if the database is there. And then the application container is started with the link to the ambassador. So the application container thinks it's a Docker link on my machine to the database. But actually it's not a database, it's just a TCP reverse proxy that finds the actual database through the configuration state, right? And then your application container gets a sidekick that enters the information in etcd so that the load balancer can find the actual application. So you have a pattern for that, and it's easier to keep those informations outside of your application and your containers. You even want to run Docker containers from the hub that don't know nothing about your infrastructure and how you connect your containers. Most probably they already know how to handle Docker links, and so you still have that feature. You have Docker links, but they're distributed with a TCP reverse proxy. So that makes it easier. And yeah, you have Console. Console does service discovery with DNS, so you can ask Console for the other services. As I said, Console has like Raft integrated, so it's more of a combined product. In CoreOS you have like etcd and Fleet, they're separated, but Console has that all together. You have like the Raft, and you have the Gossip protocol to find the servers in the cluster, and you can even have the Gossip ask other data centers for service and to get information from that service. So console is very interesting, but I hadn't had the time to look. Huh? It's new, yes, and yeah, next time. And you have like etcd, as I explained, and Kubernetes is actually using etcd. Google is using etcd as well. It's from CORS, but they're using it, and so you have a similar ambassador pattern. They have a proxy running on each node, and it looks into etcd and makes a watch on etcd's keys, and so you can have services that have a certain port on those proxies. So it's kind of similar to the ambassador pattern, and you can have like HA proxy, of course, but you have to restart it. It doesn't load your information from etcd automatically, but you can use something like conf or configurator, and they're writing out HA proxy config files from etcd or console, and you just have to restart HA proxy. Yeah. Do you know Blender? Somebody knows Blender. Yeah. It's Plan 9, and they had like really interesting concepts. I think end of 80s, beginning of the 90s. In that Unix, that everything is a file system, which we now also have like the C groups and proc file system, and all communication is transient, no matter if it's like local or on a different host, and it's through the file system, and that many of those things are inspired by that. Actually, the Go inventor was also working for Blender. Docker libchan is another library which is not ready yet, but was announced on DockerCon, and but it's quite interesting because many think about Docker container networking on layer 2, but this is on a higher level. So you have, for instance, Unix sockets inside your container. Like you have no networking in a container, but you get a Unix socket you can talk to, which is actually going outside of the container to your reverse proxy, ambassador, whatever, which is finding the way to the other container. And so you have no problem inside of the container to have like networking and how it works, right? And you have like HTTP2 to have multiplexing, and you have TLS to actually do that across your data centers. But still an idea. No, there are already implementations for that, but that's really rough at the moment. And so you have raw TCP, and you have a 0MQ, 0 RPC like messaging system over libchan, which is similar to Go channels. And Go channels are actually how the subroutines in Go communicate with each other. So that's quite nice. And yeah, monitoring logging. Actually, I found even worse pictures, but they were always so small of containers failing. That was fun. Yeah, keep it outside of your containers, of course. You don't want to have that in your application container. You have a separate container for it. And to get more information about your system or your containers running, of course you have to start those containers with more privileges than you would start in application, right? And so in Marathon you have like /metrics, and then you find metrics about your system. which is mainly for containers and watching containers and getting metrics about containers. Yes, I mostly said those things already. So they say it's like Upstart for distributed system. That's Marathon. I don't know. I like Upstart, but so and it's not systemd. No, you have constraints which are similar to Fleet. So you have like metadata for your servers, and you can say this job just has to run on certain kind of server with the same metadata, like really big CPU or huge data store, or data center A and data center B. So that's yeah, you have health checks. So if it fails, it gets restarted. And service discovery and load balancing is actually you have Zookeeper inside of Mesos, and so you have a script which generates HA proxy file, and you can restart your HA proxy. That's how they do service discovery. Yeah, you have REST API, and you can build some more yourself. Yeah, I have a small demo. So sit down. So this is the website. If you start the mesosphere, it's called Playa Mesos or something, a vagrant image, and you have like you have Mesos and Marathon pre-installed in a vagrant image, so you can see and play around a little. This is how Mesos looks, and this is Marathon, and you can create a new app here. And you can also do that on your command line. So you see, I do a post to v1 app start, and it's sleep 60 and 3 instances of that. So there's the sleep 60. I think only 2 work. I don't know why. So yeah, it's running, and after 60 seconds, it's fading, not fading, but it's finished, and then it's restarted again. So pretty simple. As I said, Mesos gave me a hard time, so I didn't play more with Mesos than that. Kubernetes. Yeah, that's hard to explain. No. It's actually not that hard. You have a master over there, and you have nodes that connect to the master. Actually, the nodes are there to run Docker containers, and the master is for scheduling and watching and stuff like that. So you have over there is kubeconfig, right, in the headline. This is your command line tool. You speak to the master with kubeconfig, and you can create pods, which are like groups of containers that are close, that are on one system, on one host, and they're closely related. So they have the same network namespace, and you can think of those container groups as if they are those sidekicks, ambassadors, logging stuff like that. You have you have your application container, and you have other containers that are sidekicks, partners, however you call them. And those are inside of one pod. So it's not that you have like your Ruby application, your database, and your load balancer inside one pod. You separate them, but you have like those configuration stuff around. And you have labels, so you can give all your pods labels, and actually services and replication controllers need those labels to find the pods. Services are just for service discovery, so if you create a service for your pod has a certain port on the proxy. It's just giving it a port, a fixed port, so that it is reachable. And you can even have like multiple instances of the pods. You can scale them, but you still reach them through the fixed port you gave the service with the service configuration. And replication controllers are you have a template of a pod, and replication controllers take care, like you want to have 3 instances of that pod running. The replication controller looks if there are enough replicas running. And on the master you have the API server, which is REST, and you have the controller manager, which actually looks if everything is running, it's okay. You have scheduler, and you have etcd. And on the node, you have Docker running, you have kubelet, which watches etcd for changes. If there is a new request for a container, you can even talk to the kubelet service via HTTP and tell them to start a container. You have CAdvisor for monitoring metrics, and you have the proxy for your service discovery. A short demo. Actually, maybe it's interesting for you. So I run everything in containers instead. So Kubernetes is running in a container, and also Docker. So I'm spawning containers in a container, and with Docker it wasn't that easy for me. So I wrote my own Docker, which is called Conair. And Conair are containers cooling containers that need the system of the ship for cooling. And actually, I use systemd nspawn for it, and I'm running systemd init inside of the container, which you probably wouldn't do with Docker, and I wouldn't recommend doing that. But if you have to run multiple services inside of a container, then it's easier to have a process manager inside of your container, because with Docker you have the problem. If you start a service like systemd service with Docker, you're actually starting the Docker client and not the Docker server. So the Docker client is telling the daemon to run another process, which is not under this process tree. It's a different process, and so you have a break between systemd and Docker at that point, and then you have like Docker as a process manager, and then inside of Docker, lots of people are using supervisor D. So you have another process manager inside of your Docker container. So it breaks like 2 times, and it's not very funny. And to have like systemd like inside the container and on the host it's really easy. So I have to look for So you can use machines CTL, which is from systemd, and you find there's already a container running. This is my Kubernetes container. I can do like Kubernetes KS, and it has this IP, and I can do look at the Docker daemon inside of this container, like from the host, right? Like the minus capital M says, okay, look for the job inside of the container, which makes it really easy. And you can even restart your services like that. So you can use like system, CTL, restart, Docker, right? So that's very convenient. So if you have like multiple jobs, multiple services running inside of a container, it's really easy. But it's only tested on Arch Linux, and it's only it's running on cores actually, because they are also very new. So it requires systemd 215, and so yeah, because I'm using networkd, which is also quite nice, because I have like automatically set up a bridge that is a DHCP server, and my containers fetch like IPs from the DHCP server. It's just, you know, not many dependencies, you just need systemd and my Go binary. So Kubernetes is running. We can look at Kubernetes by, let's say, machine status. So you can see there's etcd, Docker, the controller manager, the C advisor. Because I'm mixing master and nodes, so CLibrary running a Docker container and some EasyBox stuff that Kubernetes uses to bootstrap the images. And so last thing is you want to run an application that talks to Redis, and this is a replication controller, and you have the template here, for template, manifest, and you have the current weather. So config examples, weather, JSON, create representation controllers. This is the URL of the API. So, yeah, now it's running, and we should see it. Where it is here, maybe. It's not running. Show you the CLibrary. So actually there's not much information at the moment, but what happened? But you can see usage. I don't know why there's no container information at the moment. But maybe because of containers inside of containers. Still not there. There it is. You see the Docker is running here. Just 1 second ago. Okay. There. Fading, probably fading. I don't know. It did run before, but yeah, no luck with the demo was. So, chorus. I told you a little already. So, chorus is a stripped down Linux. It's based on Gentoo, mostly because of it's inspired by Chrome OS, and Chrome OS is also based on Gentoo, and they have stolen the Omaha protocol way of updating the system. So you have a read-only root partition that gets an overlay, like you have with the Docker containers, like you have Btrfs, copy on write, and you have like an overlay over your read-only snapshot, and so it downloads a new version of CoreOS right beside your running cores, and you just restart the system, and then you have the new version. So it's a cluster, and it takes care of who is starting when and now, and so it's restarting, but then you have like clean core as, and you actually have like not much installed. It's like 118 megabytes, I guess, and people ask on the mailing list, like, oh, can you add this tool, can you add that tool? And they always say that, oh, okay, start with a container. That's fine, you can use it. You can even start privileged container and you can do the things you want to do. You can map either sys or proc or whatever, read only to your container and read from it. And so everything is possible inside of containers. And they decided to have like Docker built in for packaging of your applications. Right? And to have the cluster running, they have like etcd, and Feed and etcd are like really leading edge. They announced support like some weeks ago, I guess, but actually it's not something you want to run in production. It's really not production ready. But those are small tools, and I think they will figure out the issues, and they are really active. Like if you're in IRC on the weekend, they are still like they're hacking all day. Like they're distributed, and so they are hacking like all the time. Like, I think one of them is also working on systemd. He created network B for systemd, and like pretty interesting people working for the project, and it's really promising. And I really like the Unix philosophy about that. So yeah, Locksmith is the tool that handles the updates. And it talks to etcd and communicates around the cluster which machine is going to restart soon and stuff like that. So you can handle that. It works. Yeah, systemd is systemd for the cluster. It's actually just an API to talk to systemd or to talk to Fleet, and then Fleet takes care on which machine systemd unit is started. And you can even use like not only services, you can also use mounts and sockets and all the other stuff you have to handle with systemd. And so you can have like containers with sock activation, for instance, right? And the scheduling is really simple. It's not that advanced like the Google stuff or Meso stuff, and yeah, you simply have like health checking failover. So if one machine goes down, Fleet takes care that the job is scheduled to a different machine. So again, demo. Yes. So now I'm gonna start the stuff. And trying to use my old cluster because the images are already fixed. But I'm starting not too fast. Maybe SQ will survive otherwise. Or maybe I have already built it. Yeah, maybe it's not working. I don't like this. As I said, the networking is sometimes really picky. I'm doing the same. So I recreated the bridge. And containers again. So now I should see them running, and I have shortcut for my local fleet command, which is actually alias to the tunnel to on-air ID, like the first machine of the cluster. So it's copy commando with machines. No! So I'm but now the images are gone. So yeah, that's fun. Like actually, if you're developing something for this, and response is the feedback cycle is short, and it's so much quicker. If you have to boot up favorite instances and shut them down, it's just like taking hours and not taking hours, but yeah. And my batteries warm, and machines heating up and stuff like that. Okay, so now I have a feed cluster, and you can list your system units, which are empty. So I prepared some units, which is actually our application. So I release that on the cluster. That's using fleet CTL start and then the service line. That's the only thing it does. So now you can list the units and maybe make it a little more. Is that okay? That? Is it okay? So you see they're starting, so at the beginning they're fetching the images. Some of them are still in inactive mode because they're dependent on other services. So inside of the unified, you of course have something like you want to register your app for your load balancer, so it requires the app to run first, right? It's required and after, and so it waits until hey, they're all ready. So fine. And now I have my swarm running. And yeah, actually that's our tool, and I can just show you an example of our JSON, which is kind of similar to what Google does, but I think it's kind of easier because you have different JSON files. So you have like one JSON file that defines different components. You have like the weather component over there, here, the weather component, the image, the port, and the dependency on Redis, and a domain, and then you have the Redis, the image, and the port, and you can say swarm, create, example, weather, and then you can ls, you see there's a weather app, okay, I want to start that weather app, so it's starting, and then you can look at the status, there what the post components are starting, you can still look at the feed cluster, and you see there are lots of containers started because there are ambassadors and presence containers and other stuff.
That's something you do not have to take care of, right? So the rest process is abstracted, but
No, it doesn't do any ambassador stuff.
but you do this.
Yeah, we do that.
So you just have your JSON, you have your service, so just define the service, and it will do everything,
Yeah, yeah.
import it in the containers for the ambassador, so everything you need to know.
I won't dying. What? Yeah, adoption is there. So you have like CoreOS on Rackspace and CoreOS on GCE, and they're starting to, working together. And, like Google said, CoreOS is a system they always wanted to have. They thought about open sourcing their operating system, but then they found CoreOS and they said, oh fuck, this is the operating system we always wanted to have. So,
I think now is the time to start a new ecosystem. I think we can only lead us when we now start.
Yeah, at least it's really interesting, and we have to find the sweet spot between security of hypervisors and stuff like that, and those kind of things. Right?
I think for now you can use it pretty good for testing. It's red test. You build the box with Hacker. You have the same template. You have the Ember box or Data box, and the testing box are filled with Docker. And then you can just run testing on test. Run test is pretty fast.
Actually, like really many tools on my computer are inside of Docker. So if I, for instance, use AWS, this is inside of a container. So it's not installed on my machine. It's an alias to Docker run, and I have like lots of tools, like my Go environment, Ruby, my Node.js, NPM, stuff like that. It's all running inside of containers, and I'm just bind mounting my current directory inside of the container. does something, and then the container is just removed, gone, and I have like only the copy of the files and data on my system.
Which is a really perfect way to work, because actually, let's say there's a thing like RVM for Ruby or virtual for Python, where you really need tools to really separate your environments and not mess up your libraries and everything. So that's really just as so I was really impressed by when you showed the working environment, because it's exactly, I was just thinking this is a perfect way to work, because you just spawn a container, just install everything you need for the particular task, and then you won't mess up anything else, and you can replicate it, and so this is,
And it stops these words, these wiki pages, do that, you can start these container groups and it works.
Exactly.
And other people can do the same as you.
Yes.
I always figure out something really opinionated, put it in there, and nobody wants to do it.
It's not like
it's just for me.
it's not like about if you just build a very small script or whatever, you just need to hand over file. This is something you don't need, because with the infrastructure you can just provide a version controlled snapshot of what you do. And this is really cool.
And it's really nice to have Go, because you can really have Go inside of BusyBox, and it's so small, and you have like 4 megabyte container, and everything is inside, and not like a full Ubuntu with 200 plus megabyte, and then Java environment inside. That's actually it's really nice. Okay. Questions?
Habe ich überzogen.
Thanks a lot.